Okay, so this is the first problem on the work that you are working on today. So we're just going to kind of go through it, talk about it, make sure everybody's on the same page. The first thing you have to ask yourself is, what side are we going to be working on? Well, we want the more complicated side. So obviously we would be looking at this side. Okay. I want to make sure, first off, that I don't have any kind of common factors. Something that could be something that both sides could be divided by. Well, I've got secant and I've got tan sine. Those don't have anything in common, so I don't have to worry about a common factor. I can go straight to rewriting in terms of sine and cosine. So according to my formula sheet, or your foldable, secant, okay, that's what we're looking for, secant is equal to 1 over cosine. So I'm going to come in, I'm going to rewrite that. Okay. And then according to my quotient identity, tan is sine over cosine. And sine x doesn't need to change. It's already in terms of sine and cosine. All I'm going to do is I'm going to change it into a fraction by putting 1 in the denominator. But I'm doing it in black just to show that it really didn't change. We're still trying to prove that it's equal to 1 over secant. So now I've got to think about PEMDAS, okay? According to PEMDAS, I would handle multiplication before I would handle subtraction. So I need to work on this first, okay? So when I multiply fractions, the first thing I'm going to look at is, do I have anything that shows up on top and on bottom? Something that could cancel out. Here I do not. I've got sine on top in both places, but I don't have any signs on bottom, so nothing can cancel out. So I'm going to just multiply straight across the top. So I've got sine x times sine x. That's sine x squared. And I've got cosine x times 1. That's cosine. So at this point, we've gotten it a little bit more simple, okay? Remember, we're not adjusting this side. We're only adjusting one side. Now I've got two fractions being subtracted. Regular fraction rules don't change. You have to have a common denominator in order to add or subtract fractions. I have common denominators. They both are cosine, so I don't need to worry about that. I can just rewrite the entire fraction over one denominator. Oops. And I'm going to stick the sine up into the numerator. So I'd have 1 minus sine squared still not really working this out very well, okay? It's still not finishing up yet. So I need to do a little bit more. Well, that numerator kind of looks familiar to me. I've got 1 minus sine squared. So I've got something squared and I've got a 1, which automatically kind of tells me that I should be going in to check out these Pythagorean identities, okay? I don't have one that looks exactly like the 1 minus sine squared that I want, but I do have sine squared plus cosine squared equals 1. So I need to kind of manipulate it and move things around a little bit. So I'm going to do that kind of down here, and then I will go back up. So that is what the Pythagorean identity actually is. I want 1 minus sine squared on a side by itself because I need to figure out what that equals. Well, if I subtract sine squared from both sides, I now have that 1 minus sine squared that I needed. Okay? So 1 minus sine squared is equal to cosine squared x, which means I can come back up to my problem and I can rewrite this 1 minus sine squared as just cosine squared in order to kind of simplify it a little bit. Okay, so this is where I'm at right now. I've got cosine x squared over cosine. We need to remember exponential properties. Exponential properties tell you that if you have two bases raised to exponents and they're being divided, you would subtract the exponents. So the exponent here is 2, the exponent here is 1. What is 2 minus 1? 1. Because it's a positive, it tells me that the cosine to the first power is going to stay up top. So really quick, if I were to go back to my formula sheet, it does in fact say that cosine is equal to 1 over secant. So if cosine is equal to 1 over secant, it can be rewritten as 1 over secant. You are finally at the end. Your two sides are equal to one another. And you're done with this problem.